Okay, let's balance this equation. This is the formation of ammonia from its elements. It's a very important chemical reaction. In fact, most of the nitrogen in your body was formed by this reaction in something known as the Haber process. But that's beyond the scope of this talk. So, to balance this equation, first thing we do is list the elements down the side. So we have nitrogen and hydrogen. Okay, there's nitrogen and hydrogen in the products as well, right? But we don't need to write down ammonia here. We have nitrogen and hydrogen in the reactions. They'll be in the products. Law of conservation of matter, right? So the next thing we do is figure out how many atoms of each element there are. So we're going to put these numbers down here. There's 2 nitrogen atoms in N2, and in ammonia there's only 1 nitrogen atom. So we'll put a 1 there, and I like to line them up right underneath the elements. This is a simpler equation, but when they get a little busier, it's a lot easier if you keep them lined up underneath the element they correspond to. So for hydrogen, I'm not going to put it here, I'm going to put it over here. We have 2 hydrogens in H2, and in ammonia we have 3 hydrogens in NH3. Right, so 2 does not equal 1. Right, think of this reaction arrow as an equal sign. Well, they're not equal. We can fix that with the coefficients. So the next thing we do after we determine how many atoms of each element there are in both reactants and products, we apply coefficients to balance the equation. So 2 equals 2 times 1. That 2 is going to go up here on this line. Remember, we only apply coefficients. That's why I put these lines here. We never mess with the subscripts when we're balancing a chemical reaction. So put the 2 here, so 2 equals 2 times 1. The nitrogens are balanced. But every time you apply a coefficient, make sure you re-inspect to see what else this 2 might apply to. This 2 applies to ammonia, which has 3 hydrogens, so there's 2 times 3. So I'm going to put this 2 here as well. This is the same 2. It applies to the hydrogens. So 2 times 3 is 6. We have 6 hydrogens here in the products, so only 2 in the reactants. We can fix that with the coefficient of 3. So 3 goes up here. 3 times 2 equals 2 times 3. This equation is now balanced. Alright, so let's balance this equation. Sodium chloride plus fluorine gas gives us sodium fluoride and chlorine. Alright, so that's what's given. I like to put a line in front of each substance here in both reactions and products, because remember, when we balance chemical reactions, we only change the coefficients, right? We don't change the subscripts. Right, so let's write these steps down. First thing we'll do here is list the elements, list the elements. So I'll list the elements down the side. I have sodium, I have chlorine, and I have fluorine. Don't need to bother looking on the product side. If they're in the reactants, they'll be in the product. So the second step now is we determine how many atoms of each element there are. Determine how many atoms of each element in reactants and products. Okay, so for sodium, we have a 1. 1 in the reactants, and over here in the products there's 1. So these are actually balanced. For chlorine, there's 1 chlorine atom in sodium chloride, and over here in the products we have 2. And you notice I don't put the 2 over here, I put it underneath the chlorine. It's a lot easier to figure out what's going on. When you tabulate these, keep them underneath the respective element. For fluorine, I'm not going to put the fluorine number here, I'm going to put it underneath the fluorine. So there's 2 fluorine atoms in F2. In sodium fluoride, there's just 1. Okay. So the sodiums are balanced. Chlorine, not balanced. 1 does not equal 2. Likewise, for fluorine, they're not balanced. Well, we can fix this with a coefficient of 2. So I'm going to put a coefficient of 2 here. I put the coefficients in parentheses. So the third step then is we will apply coefficients to balance atoms. Okay, I put those in parentheses. So this 2, I put it here, but I'm also going to put it up here, right, in the chemical reaction, because what I want to do next is reinspect. Every time we put a coefficient here, we reinspect. This 2 we use to balance the chlorines, remember chlorine, but it also applies this sodium. So what we're saying here now is we have 2 copies of sodium chloride. So this 2 also goes here. This is the exact same 2. Now that messed up this first row. The chlorines are balanced, 2 times 1 equals 2, but now we messed up the fluorines. So don't let that bother you. You'll see why in a moment. So oftentimes when you apply a coefficient like this, it messes something up that already was balanced, but we just have to deal with that. So 2 times 1 doesn't equal 1. We can fix that with the coefficient. Right? Again, notice we only apply the coefficient. I'm not going to put it down here as a subscript because this chemical formula for sodium fluoride is NaF, not Na2F. So this 2 goes here. Now we have 2 copies of sodium fluoride, so 2 times 1 equals 2 times 1. I forgot to write this very important first step. Reinspect. Every time we apply a coefficient, we reinspect. It basically means we go back to number 2. Determine how many atoms of each element there are. We applied this 2 to balance the sodiums, but it also applies to this fluorine. And that's the reason why you don't get too upset about this, because the other half the time you apply a coefficient, it balances something that needed balancing anyway. So 2 times 1 equals 2, and this equation is balanced. Another equation we can balance here is, let's take this one, a little bit more complicated. Aluminum bromide plus potassium sulfate gives us potassium bromide and aluminum sulfate. All right. From earlier, we know this. I'm going to rewrite the steps here. 1, list the atoms. 2, determine number of Number 1, list the elements. Number 2, determine the number of atoms. That's number 3. 3, we apply coefficients. And 4, we reinspect, which means we're going to go back up to number 2. So, number 1, list the elements. Now, we haven't seen this before, but there's a little hint here. So, underneath listing elements, there's talk about a little hint. So we have aluminum, all right? We have aluminum here, and bromine. That's good. Potassium. We have sulfur and oxygen, but if you notice, the sulfate ion here is exactly the same as the sulfate ion here. So for polyatomic ions, I'll write this down in a moment. For polyatomic ions, this is why it's really important to know your polyatomic ions. If it appears exactly the same in the reactants and products, SO4 and SO4, it doesn't matter that there's 3 of them here. This 3 applies to everything in parentheses. So there's 3 sulfates. Here there's 1 sulfate, right? But it's still SO4. We can list it as the polyatomic ion. We do not have to break it apart into sulfur and oxygen. So for polyatomic ions, list them as the ion if they are in both the reactants and products. Okay, so we've list the elements. Now we determine how many there are. Well, we got 1 aluminum and 2 aluminums. Not balanced. Bromine, we have 3 bromines. Over here there's just 1 bromine. Again, not balanced. Potassium, there's 2 potassiums. Listed underneath the element, not over here. 2 potassiums. Over here there is 1 potassium. Not balanced. Sulfur, it's not sulfur, sulfate. We have 1 sulfate and potassium sulfate, and there's 3 here. Not balanced. Okay. So 1 doesn't equal 2, right? We'll put a 2 here, and we put these lines in front so we remember only to apply coefficients. 2 times 1 equals 2. We apply the coefficient, now we reinspect. This 2 also applies to the bromines. 2 times 3 does not equal 1. 2 times 3 is 6, right? So we're going to need a coefficient of 6 here. Every time you apply a coefficient, reinspect. This 6 we use to balance the bromines, but also applies to this potassium. 6 here, right? Same 6. 6 times 1 doesn't equal 2, but 3 times 2 is 6, so this 3 now goes up here, right? 3 times 2 is 6. 6 potassiums on the left, 6 potassiums on the right. Every time we apply a coefficient, reinspect. This 3 we use to balance the potassiums. It also applies to these sulfates. 3 times 1 equals 3. So 2 times 1 equals 2, they're balanced. 2 times 3 equals 6. 6 times 1. Bromine's balanced. Potassium, 3 times 2 equals 6 times 1. And 3 times 1 equals 3. The equation is balanced.